every human being has looked up and wondered about the stars in the universe. As a radio astronomer working with the next generation telescopes, where we cannot keep the raw data, the impossible question that I work with is whether we can explore and discover all there is to explore from the universe before we chuck out the data. I'm Ivy Wong. I'm a radio astronomer at CSIRO Space and Astronomy in Kensington, Perth. So I like to look at the physical processes that drive the evolution of galaxies. Over time, I've gotten more and more interested in bigger and bigger surveys with the next generation instruments. And with the next generation instruments, this means that we have to explore and investigate alternative methods to analyze our data, because the data rates, data volumes are getting so high that our traditional methods are just not working anymore. I also work on citizen science and applications of machine learning to radio astronomy. This is a CSIRO operated site that's in WA. All the data comes down to Perth. We get stored and processed, imaged, and then distributed to the science teams and survey teams. Radio astronomy is just astronomy done at radio wavelengths. What are radio wavelengths? Radio wavelengths can span from 1 millimeter to meter scale. If we wanted to simulate, let's say, the resolution from a telescope that spans 2 kilometers, we would space out little dishes of, say, about 20 meters in size along a baseline of 2 kilometers. What we do then is we correlate the light that comes onto each dish and time-stamped so that they can be all correlated and then mathematically transform into the image that is the universe. What is interesting is that in the radio frequencies, we get to look at sites of star formations. For example, if, let's say, the central supermassive black hole of a galaxy was gobbling stuff out, the feedback effect would create these magnetic fields that spiral out these huge radius plasma that we see in the sky. So if our eyes were able to see the sky in radio, and so it's only by piecing together all the information together we hope to shed light on how galaxies evolve. The supercomputer holds the data and calibrates the data and then does that transformation. If we allowed our hardware to capture as much information as we can get up to 100 petabytes or more a year. So we're not fully recording everything that we could because we simply don't have that capacity to process such vast volumes of data at once. My focus for the next couple of years is trying to apply machine learning methods towards the spectral line surveys. Thereby we can model actual galaxies in 3D rather than just have it as flat 2D postage stamps all over. I was always one of those curious kids who asked why and tried to find out how things work. Why is the sky blue? And so I was always wanting to do a science-related career. I started as an undergraduate in second year doing a vacation scholarship with the astronomy group at the University of Melbourne, who then sent me up to the Parkes Radio Telescope to work on the high-pass survey. When I became a PhD student, I was a CSIRO ATNF student. Then I completed my PhD, went abroad for a postdoc, and then returned again as a postdoc at CSIRO, but in Marsfield in New South Wales. And most recently, in January 2020, I started my position as a CSIRO science leader here at Space and Astronomy in Kensington. All the scientific publications, talks, datasets that I've released into the public are formally my legacy as a scientist. But because I also mentor students, hope that in some way my legacy will live through their work as well. What fascinates me is that actually, to answer these big questions, you need really good teams that work well together. What I like to see is that we celebrate scientific talent as much as we celebrate talent in other areas like sporting ability, artistic skill. I think that impact would be tremendous and game-changing because we do have a lot of talent on show. We have very curious people, we have very bright kids with capabilities that we haven't even figured out that we need yet. So there's many phenomena that are still yet to be discovered because radio astronomy is one of the newest and youngest observational science in astronomy itself. As part of our CSIRO's Radio Astronomer, we're hoping to ask and answer the impossible questions that have not been asked or answered before.